Okay, so here's what you had to do. You had a series of 3 moves, and I've seen it everywhere. Some of you went like this, 1, 2, 3. There's the first move. 4, 5, 6. There's the second move. I think this was yours, Andrew. 5, 7, 8, 9. Okay, or it's some combination thereof. So you had this pattern. Look at the ones that I said were right. You had this pattern somewhere in there. You had this pattern somewhere, except you could not start with this one. So this is either going to be at the middle or in the end. And then you had this pattern. So you either started like so, or you started like so. Every one. Am I correct?
Yeah.
We have the same bottom.
But my point was that this exercise, you had to start one way, and then you had to keep coming back to it. Now, unlike Andrew, but my guess is you've done these before, so you've learned this over a period of time, right?
No, first time I did it.
First time?
No,
Okay, well, he's the exception. Normally, you have to come at it. You start one way. You go down an avenue of thought. It doesn't work out, and so you have to start over and go down a different avenue. And that's what is going to be the case in Chapter 6 as we introduce trig identities. All right? So this is why students spend a lot of time in frustration with trig identities, because they want it just to work out just the first time. And it doesn't always work out the first time. You have to start one way and try to attack it from one avenue, and if it doesn't work out, you have to come back. So let me encourage you, don't get frustrated if at first you don't succeed. All right, just keep on trying. So let me introduce some of these. We've talked about these before with graphs as far as sine of x was well, I think we saw that cosine of negative x was equal to cosine of x. You remember graphing those, and we had one that was secant of negative x, and it was the same as secant of x, and so on and so forth. I introduced those to you purposefully because these are trig identities. Tangent of negative x will be negative tangent of x. And why does that work out the way it does? Well, it works out that way because if you think about putting in negative x, what's going to be my output on the unit circle? It's going to be the same y, right? So negative cosine of negative x is going to equal cosine of x. But sine, if I put in negative y, what's going to happen? It's going to be negative sine because we're moving down into where y is negative. Now, the other parts of it have to do with Pythagorean identities. I don't know why my stand isn't working here. Think about the unit circle. We've got our unit circle here, and I've got my radius of what? What's the radius on the unit circle? 1. And I've got some distance x and some distance y, and this point up here is x and y. Now, the Pythagorean theorem would say what? That x squared plus y squared equals the radius squared, 1 squared. And what is 1 squared? 1. And what is x on the unit circle in terms of a trig function? Yeah, it's cosine. I'm going to zoom over here. Can you all see the unit circle over there? Hey, Nicholas. Cosine over there. And then what's y in terms of that? Sine of x. So we can rewrite this as sine squared theta plus cosine squared theta equals 1. That's called a Pythagorean identity. You understand how I'm deriving that from just the unit circle data that I have? Then if we divide through by sine, what's sine squared over sine squared? Well, it'd be 1, right? Something divided by itself. So 1 plus cosine squared over sine squared, which is going to be what? Cotangent squared, is going to equal 1 over sine squared. Now, what's 1 over sine? What's the reciprocal of sine? Do you remember? Not secant, but cosecant. So we get our bottom identity here, 1 plus cotangent squared theta equals cosecant squared. If we divide through by cosine, we get the same thing. Sine over cosine, tangent squared, cosine over cosine, 1, and then 1 over cosine secant. So 1 plus tangent squared equals secant squared. We call these things Pythagorean identities. Okay, named after Pythagoras. So let's do a few of them here. Multiply and simplify cosine x times tangent of x minus secant x. Well, what would my first term be? It'd be cosine x times tangent of x. And my second term? Well, cosine times what? Cosine times secant. Now, if you're taking notes, write this down because this is worth the price of the course, at least in this chapter. One of the primary strategies is to turn everything that's not sine or cosine into something that is in terms of sine or cosine. So what is tangent in terms of sine or cosine? Well, if I look over at my unit circle, I have tangent as y over x. What is y on the unit circle? Sine and x. So tangent is sine over cosine, right? So I can say cosine of x times sine of x over cosine of x. And what about secant? What is secant in terms of sine or cosine? It's the reciprocal of cosine, right? So I would have cosine of x times 1 over cosine of x. And then notice what happens. My cosines cancel, and I've simplified it down to sine of x minus 1. Okay? Now if we continue on, factor and simplify sine squared cosine squared plus cosine to the fourth of x. Do I have any like terms? Cosine what? Squared. So if I factor out cosine squared of x, I'll have sine squared x plus, what's this? Ah, now does this look familiar to you?
Would it still be cosine squared x and secant x?
Mm-hmm. That's just 1, right? That's a Pythagorean identity. So what's cosine squared x times 1? Cosine squared x. Well, let's hope. Yeah, maybe. I don't know. What's cotangent of negative x? Well, let's go back to my my stuff here. Cotangent of negative x is going to be negative cotangent of x, right? So if I come down, where was I? Right here. Over cosecant of negative x. So let's see. That would be cotangent, negative cotangent of x over negative cosecant of x. What happens to my negatives? Cancel out. So I would have cotangent of x over cosecant of x. And then what would be my strategy here? It's to put things that are not in sine or cosine into terms that are sine or cosine, right? So what's cotangent? Yeah, but that's not sine or cosine. It'd be cosine over sine, right? And what's cosecant? 1 over sine, yeah. 1 over sine. So then what happens to my sines? They cancel, and I'm left with what? Cosine of x. Very good. My negatives are going to cancel. Yeah. All right, let's do one more here. Simplify 2 sine squared t plus sine t minus 3 over 1 minus cosine squared t minus sine t. All right, I'm just going to work this one, and then I'll see if you guys can follow me, all right? So let me work the numerator first, and I'll say that x is equal to sine of t, and so that'll give me 2x squared plus x minus 3, which will factor down to 2x plus 3 and x minus 1. Now let me work the this one here. What would that one be? Well, I know that this plus this equals what? 1. So if I subtract cosine squared over to the other side, what would I have? I'd be left with that, yes? So I'll have that over sine squared t minus sine of t. And what can I factor out of both of those? Sine of t. So let me reintroduce sine of t here. I'll have 2 sine t plus 3 times sine of t minus 1 divided by, let me factor out sine of t here, and I'll get sine of t minus 1. Well, would you look at that? What happens? Those cancel, and now I'm left with this here. So let me separate these out. I'll have 2 sine t over sine t plus 3 over sine t. Those cancel, and I'm left with 2 plus 3 cosecant t. You follow me there?
1 over sine.
1 over sine is cosecant. Okay, let's go back and look at my steps real quick here. Everybody follow that I did substitution here? And then I factored, right? So once I had factored, then I used my Pythagorean identity for these two terms to get to that. Then I factored those two terms out to get to here, and I re-substituted in there. Those quantities cancel. Then how did I get from here to here?
You split them apart.
I split the fraction apart, right? 2 sine t over sine t plus 3 over sine t, which is the same thing. Then my sine t's cancel there, and I convert that to cosine. Okay?
What did,
All right. 2 through 50 evens today is the assignment. Good luck.